Okay, so let's continue our discussion in the techniques of integration. Of course, is still in trigonometric integrals, but now with the power of cotangents and coseconds. So m is the power of our cotangent and n is the power of our cosecant. So these are the cases. So apply natin sa mga examples. So example number 1, the integral of cosine 5 2x over sine raised to 8 2x dx. So, anong gagawin natin dito? So, first is hanap tayo ng identities nila. So, how do we do that? Dapat yung power nung nasa taas and yung nasa baba is parehas. Kasi we all know that cosine over sine is cotangent. Okay? So, this will be equal to cosine raised to 5 2x all over breakdown natin si sine raised to 8. So, gawin natin na sine raised to 5, 2x times sine raised to 3, okay, 2x dx, okay. So, from there, we can rewrite our um, expression as the integral of cosine raised to 5 2x all over sine raised to 5 2x times 1 all over sine cube 2x and then dx. So, cosine over sine is equal to cotangent. Okay, so this is cotangent 5 raised to 5 2x and then 1 over sine is cosecant. So, cosecant cube 2x dx. So, we now have the format of the power of cotangents and cosecants. So, our m is 5 and our n is 3. But first, mag-let u muna tayo. So, let u be equal to 2x, our du be equal to 2dx, and 1/2 du will be equal to dx. So we can rewrite this as cotangent 5u times cosecant cube u 1/2 du. So we can isolate si constant and then we will be left with cotangent 5u cosecant cube u du. Now our m is 5 and n is equal to 3. So, what case will we use? Since m is an odd integer dito sa part na to, we can use si case 1. Okay? So, use case 1 for this problem. Case 1. And we can rewrite 1/2 times, okay, mag-minus 1 tayo to the both of the powers and then we substitute cotangent squared u with cosecant squared u minus 1. So, this will be equal to cotangent 4u tapos cosecant squared u and then cotangent u cosecant u du. Okay, so for this one, this is cotangent squared u raised to 2. Okay? And then cosecant squared u and then cotangent u cosecant u du. So we are going to substitute cotangent squared u with cosecant squared u minus 1. So this will be equal to 1/2 times cosecant squared u minus 1 quantity squared times cosecant squared u cotangent u and then cosecant u du. So, this will be equal to 1/2. Expand natin. This is cosecant raised to 4u minus 2 cosecant squared u and then plus 1 multiplied by cosecant squared u, cotangent u, and then cosecant u du. So, distribute natin si cosecant squared u dito. So, this will be equal to 1/2 times cosecant raised to 6u minus 2 cosecant raised to 4u plus cosecant squared u multiplied by cotangent u cosecant u du. So, from here, let us mag-assign ulit tayo ng variable. So, let P be equal to cosecant U. So, our dP will be equal to, what is the derivative of cosecant? That is negative cosecant U cotangent U du. Okay. So, para ma-omit natin si negative dito, magiging negative dP, or dito na lang natin ilagay. Negative dP is equal to cosecant U cotangent U du. So, we can use negative dP to substitute yung part na to. So, our new equation will be the integral of cosecant U is P. So, this is P raised to 6 minus 2 P raised to 4 plus P raised to 2, and then cotangent U cosecant U du is equal to negative dP. Okay. So, from there, ilabas natin si negative, ilagay natin dito, isolate natin. So, our new expression will be, or equation is equal to negative 1/2 times the integral of P raised to 6 minus 2P raised to 4 plus P squared and then dP. So, we are now ready to integrate. So, this will be equal to negative 1/2 times P raised to 7 over 7 minus 2P raised to 5 over 5, and then plus P raised to 3. Sorry. That is P raised to 3 all over 3, and then plus C. So, we distribute C2. This will be equal to negative P raised to 7 over 14, and this will cancel. So, this is negative times negative, positive. P raised to 5 all over 5. Okay, magka-cancel na sila. And then, for this one naman is negative P cube all over 6, and then plus C. Now, back substitute tayo. What is P? P is equal to cosecant U. And U is equal to 2x. Therefore, si P natin is cosecant 2x. So, yun yung ibaback substitute natin dito. So, this will be equal to negative cosecant raised to 7 2x all over 14 plus cosecant raised to 5 2x all over 5 minus cosecant cube 2x all over 6, and then plus C. So, that is the answer for example number 1. Now, let's try example number 2. Si cosecant raised to 6x dx. So, ano ang gagamitin natin? So, yung m natin is 6. Okay, so we can use C case number 2. Okay, since m is odd dito sa number 1, we cannot use that. M is any positive number and n is 0. So, we cannot also use that kasi, no, we can use si case number 3. Okay, sorry. Si case number 3 pala yung gagamitin natin dito because we don't have a cosecant. Okay, so case number 3 tayo. Ayan. So, in case number 3, mag-minus 2 tayo dito. So, this will be equal to cosecant 4x times cosecant squared x dx. And from there, this will be equal to cosecant squared x quantity raised to 2 and cosecant squared x dx. So, ano yung papalit natin kay cosecant squared x natin? That will be equal to 1 plus cotangent squared x. This is according to case number 3. So, this will be equal to 1 plus cotangent squared x quantity squared times cosecant squared x dx. Now, if we try to expand this one, this is equal to 1 plus 2 cotangent squared x plus cotangent raised to 4x times cosecant squared x dx. And mag-let u tayo. So, let u be equal to cotangent x, du be equal to, what is the derivative of cotangent x? That is negative cosecant squared x dx. Therefore, to omit yung negative natin dito, magiging negative du is equal to cosecant squared x dx. So, if we rewrite this equation, this will be equal to 1 plus 2u squared plus u raised to 4 times negative du. And for our negative sign, we can omit that. Ilagay natin dito. We can isolate. So, this will be equal to negative the integral of 1 plus 2u squared plus u raised to 4 du. So, this will be equal to negative u, the integral of 2u squared plus 2u cubed over 3 plus u raised to 5 over 5 and then plus c. Okay? And then plus c. So, from there, back substitute tayo. So, what is u? That is, yan, si cotangent x. So, this will be equal to negative cotangent x minus 2 cotangent cube x over 3 minus cotangent 5x over 5 plus c. So, this is the final answer for example number 2 in the power of cotangents and coseconds. Now, let's try example number 3. Okay, so the example number 3 natin is the integral of cotangent 5 4x. Okay, correction lang. For our example in number 2, hindi case 3 yung ginamit natin. Okay? That is si case number 2. Sorry for that. That is si case number 2. Bakit? Because n pala yung meron tayo na power, hindi pala m. So, yung process is okay, ganun din. Yung sinubstitute natin is from case number 2. Okay? So, yan. Tama naman yung procedure, tama yung process, tama yung solution. Wrong lang yung nalagay ko na case na gagamitin natin. Okay?